In this video, we are looking at lenses. Have you ever wondered how binoculars work? How do they make things look closer? Well, binoculars work by using lenses. A lens changes the direction of light by refraction. There are two types of lenses you must learn about. First, there is a convex or converging lens. Notice how it's thin at the edges and thicker in the middle. It has two focal points either side of the lens labelled F. Also notice how incident parallel rays of light coming from the left are then refracted towards the focal point on the right. There is also a principal axis which is drawn by the horizontal white line. The second type of lens you must learn about is a concave or diverging lens. This lens is thicker on the edges and thinner in the middle. It too has a principal axis drawn by a horizontal white line and a focal point both sides of the lenses. Only one is drawn in this diagram, labelled F. Notice how incident rays entering from the left are then refracted away from the principal focus, also on the left. The rays of light are moving away from each other, hence it is called a diverging lens. You must also be able to give applications of both of these lenses. For example, a convex lens is used in binoculars, camera lenses, and magnifying glasses, whereas a concave lens is used to correct short-sightedness. So let's have a look at the convex lens in more detail. When the object is a long way from the lens, an image is formed at the principal focus. This is because for very distant objects, the light rays coming from it are almost parallel, and the image formed is real. So what is a real image? Well, a real image is an image that can be projected onto a screen. This is because the rays of light actually pass through the image. In this example, the image is formed at the focal point on the right. Notice how the light rays actually pass through that point. So what happens if you start to move the object? Well, if the object is moved closer to the principal focus, the image moves further away from the lens. The image also gets bigger. If the object is between the principal focus and the lens, the image is larger than the object, and the image becomes virtual. This is a magnifying glass. You might be asked to calculate the lens magnification. This is equal to the image height divided by the object height. If the magnification is greater than 1, the image is larger than the object, whereas if the magnification is less than 1, the image is smaller than the object. Finally, magnification is a ratio, so there are no units, but make sure the units used for both heights is the same. Okay, so time for another quiz. So, what do lenses do to light? Name two types of lenses. What type of lens is this? What does a concave lens do to parallel incident rays of light? What was represented by the horizontal white line passing through the centre of our lenses? What did the letter F represent in our lens diagrams? What type of image is formed by a convex lens when the object is a long distance away from the lens and where is it formed? What happens to the image formed by a convex lens if you move the object from far away towards the focal point? What happens to the image formed by a convex lens if the object is between the focal point and the lens?